Welcome to my class. Today I am gonna solve Cambridge AS Physics paper 1. Its variant is 12 10 year October November 20. I am solving today question 1 to 20. At question 1, which quantity is a physical quantity? Faber, Kelvin, minute, potential difference. Here, Kelvin is not a quantity, it is an unit. And minute is also unit, and therefore quantity is potential difference. And in question 1, answer is 1. Answer is B, potential difference. And at question 2, what is a power of 3.7 megawatt when expressed in kilowatt? No, prefix mega is 10 to the power 3 kilowatt equals to 1 megawatt. Therefore, 3.7 megawatt, just convert 3.7 megawatt into kilowatt, 3.7 into 10 to the power 3. And this is of the megawatt, 3.7 megawatt equals to 3.7 into 10 to the power 3 kilowatt. Therefore, answer is here C, 2C. Now I am at question 3. A spring is suspended from fixed point and a force is applied. The position of the pointer attached to the bottom of the spring against vertical roller is recorded. Before the force is applied, the position of the pointer is 225 plus minus 2 millimeter. After the force is applied, the position of the pointer is 250 plus minus 2 millimeter. The extension of the spring is determined. What is the percentage uncertainty in extension? For the case of here is extension is, in this case, extension is 4 millimeter. This is uncertainty in extension. And extension is 250 minus 225 is 25. Therefore, percentage uncertainty in extension is this quantity, 200%. Percentage uncertainty in extension. If we calculate this using calculator, it gives 16%, and 16% is at answer D. Therefore, answer is for question 3 is D. Answer is D and 16%. Now at question 4, what is the difference between a scalar quantity and a vector quantity? We know the scalar quantity has only magnitude, but vector quantity has both magnitude and direction. Let me see which statement satisfy the definition of vector and scalar. A vector quantity has direction, but a scalar quantity does not. This is the appropriate description. So at 4, answer is C. Now I am at question 5. A toy car. Toy car travels on a circular track at constant speed of 0.50 meter per second. It passes a point on the track at time t equals to 0 and takes 40 seconds to travel once around the track. The magnitude of the average velocity of the car between t0 and t20 is v20. Magnitude of average velocity of the car between t0 and t40 is v40. What are v20 and v40? Let me draw a diagram. This is the track. It is circular, and here is t0, and this is here is the toy car travels in the circular path. At first we calculate the this is speed is given and time is given. Therefore circumference would be this whole length of the track would be length, or circumference would be 0.50. This is speed and time is 40 seconds. This gives we know the circumference is not relevant here, and this gives 20 meters. Therefore the diameter of this circle, if we calculate, start from here, pi d equals to 20. Therefore d equals to this diameter, this length, 20 by 3.142. This gives 6.365 meter. This is the length of the diameter, and here is the velocity. Here is the velocity v20, and at t equals to 20 seconds, the particle in fact travels from here to here. This is a straight line. This is the direction of the displacement, and velocity would be this here. Displacement is v20. displacement is 6.365 by 20. It gives 0.318, that is equivalent to 0.32 meter per second. This is V value of V20, but consider the P40. P40 is here. In this case, displacement is 0. I start from here. Displacement is 0 and time is 40. Therefore, P40 equals to 0 by 40 is 0. Therefore, if I see the answer, P20 is this and P40 is 0, and answer obviously is A. Therefore, 5, answer A. Now, I am at question 6. The graph shows how the velocity of an object moving in a straight line varies with time t from t equals to 0 to t equals to t. This is velocity time graph. Which graph would represent the displacement s of the object from time t equals to 0 to time t equals to t? We know the gradient of displacement time graph is velocity. If we consider this graph is its gradient is increasing, then decreasing, and decreases to 0 here. Therefore, this situation can be described by the velocity time graph from here to here. And from this point, its gradient changes from 0 to negative maximum, then again 0. This portion from here to here is represented by this portion. Therefore, the situation in the velocity time graph is best described by the displacement time graph at answer A. Therefore, write 6 A. Now, question 7. A goods train passes through a station at a steady speed of 10 meters per second at time t equals to 0. An express train is at rest at the station. The express train leaves the station with uniform acceleration of 0.5 meter per second square, just as the goods train goes past. The train moves in the same direction on a straight parallel tracks, at which time t does the express train overtake the goods train. Let the time be when the express train overtake goods train is t. Therefore, distance traveled by goods train equals to 10t, and displacement for the express train is s equals to, since its initial velocity is 0, up 0.5 is the acceleration, and t square divided by t square. Now solve these two equations. 0.5 t square by 2 minus 10t equals to 0. 0.5t by 2 minus 10 equals to 0. Therefore, 0.5t equals to 20, and t equals to 40 seconds. And d time is 40 seconds. Therefore, answer for the question is D, 7. At question 8, constant resultant force F acts on an object of mass m for time t. What is the change in momentum of the object? From Newton's second law, we know that force equals to mass into acceleration. Mass. Sorry. The mass can be, acceleration can be written as E minus U by T. Now multiply the equation by T. Therefore, Ft equals to mv minus mu. mv minus mu is the change in momentum. Therefore, Ft is the answer to question 8, and it is at C. Therefore, 8 C. Ft also be named as impulse, but this is not a term to consider here. And question 9, acceleration of free fall on the surface of planet P is 1/10 of that of on the surface of planet Q. Let me sketch planet P and planet Q. On the surface of P, an object has mass 1 kg and a weight of 1 Newton. 1 kg, 1 Newton. What are the mass and weight of the same object on the surface of planet Q? Mass remains unchanged at the surface of the planet Q. Therefore, it is 1 kg. But since the acceleration due to gravity is on the surface of planet Q is 10 times, therefore its weight would be 10 Newton. Now it is at answer B. Mass is 1 kg and weight is 10 Newton. Therefore, write 9. Question 10. A parachutist falls from rest from a balloon. The variation of time of the velocity of the vertical velocity of the parachutist is shown, in which region force due to air resistance much greater than the weight of the parachutist. Let me sketch a free body force diagram for the parachutist. This is parachutist, and its weight acts downward vertically, and air resistance acts vertically upward distance. We see that the parachutist decelerates significantly at region C. Therefore, air resistance is greater than weight at this region C. Now write 10, answer C. At 11, two solid sphere from isolated system. Sphere X moves with speed 6 centimeter per second in a straight line directly toward a stationary sphere Y as shown. The sphere have a perfectly elastic collision. After the collision, sphere X moves with a speed 2 centimeter per second in same direction as before the collision. What is the speed of sphere Y? The speed of sphere Y initially is 0, and collision takes place here. Then sphere X moves with speed 2 centimeter per second, and sphere Y moves d centimeter per second. In this case, Newton's law of restitution, in fact, coefficient of the restitution H represented by small e, it is equals to speed of separation by speed of approach. When the collision is perfectly elastic, the coefficient of restitution is exactly 1. Speed of separation, since b is greater than 2, b minus 2 by speed of approach is 6 minus 0. This gives b equals to 6 plus 2, equals to 8 centimeter per second, and this is at answer D. Now 11, D. What question 12, what is not necessary requirement of the force in couple? This is an object, a force act F like this, in this direction, other force act in direction. This is the center of rotation. In this case, a resultant force not always be a must. Therefore, at D, they produce what is not necessary requirement of the force in of the forces in a couple. Therefore, this is the necessary. This is not a necessary requirement. Therefore, answer for question 12 is D. Question 13. A box of length 12 centimeter, weight 0.43 Newton is placed on horizontal table with the greater part of its length overhanging the edge of the table. The edge of the table acts as a pivot. The center of gravity of the box is at geometric center. To balance the box, a uniform sphere of diameter 2.4 centimeter is placed inside the box, touching one end as shown. Assume that the force acting on the box are in the plane of the diagram. Now, center of mass of the box is here, and its weight acts in this direction, and its value is 0.43 Newton. Now, this distance from the pivot to the line of action of the weight of the box is 6 minus 2.4 is 3.6, and the sphere has diameter 2.4 centimeters. Therefore, its radius is 1.2 centimeter, and this is from here to here. Its weight of the sphere act to the as shown in the diagram. Let the mass of the sphere is m kg. Therefore, weight is mg Newton. Taking the moment about pivot, that is edge of the table, gives 0.43 0.43 Newton into distance 3.6 equals to mg into 1.2. Now m equals to 0.43 into 3.6 by 1.2 g. And it is it is equals to 0.13 kg, and this is at answer D. Therefore 13, answer D. Sorry, this 0.13 kg is B. Therefore 13, answer to 13 is 0.13 kg, and it is at B. Now at question 14, an object is suspended by two ropes. One rope has tension 410 Newton at angle 60 degree to the horizontal. Other rope has a tension 210 at angle 10 degree to the horizontal. The object is in equilibrium. Now resolve this 400 Newton into vertically gives 400 resolve this 410 Newton. 410 sine 60 degree, and resolve this 210 vertically gives 210 sine 10 degree. Therefore mass of the object, if we consider m kg and its weight to be mg. Now mg equals to sine 60 plus 210 sine 10. Therefore m equals to there is 10 degree, uh, 10 degree, and the value of g is 9.81, and this gives 39.91. 39.91, and to two significant figure, it is 40 Newton, and 40 Newton is sorry 40, it's not 40 Newton, 40 kg. 40 kg. 40 kg is at A. Therefore, answer to question 14 is 14 A. Now, question 15. A solid cube is floating in equilibrium in liquid mercury. The cube is made of iron of density 7900 kg per meter cube. The cube floats with 42% of its volume above the surface of the mercury. What is the density of the mercury? This is the cube and the level of the mercury is this, and let the volume age of the cube is L meter. Therefore, its volume would be L cube meter cube. Therefore, its mass of the cube is we know density equals to mass by volume. Therefore, mass equals to density 7900 into volume L cube, and its weight of the cube is 7900 L cube G. This is according to Archimedes principle, the weight of the mercury displaced by the cube, and mass of the mercury is 7900 L cube kg. But volume of the mercury displaced is, since above the surface volume below the inside the mercury, the volume of the cube is 58%. This is numerically equals to 0.58 L cube, and therefore volume of the mercury is displaced is 0.58 L cube. We know density of the mercury, therefore density rho of the mercury is mass by volume. Now write 7900 L cube by its volume is 0.58 L cube, and it gives 13,620.7 this is to two significant figure. This is 14,000 kg per meter cube, and this is at answer C. Therefore 15 answer would be C. Question 16. The diagram shows two vessels P and Q, both with sides inclined at 45 degree to the horizontal. Vessel P tapers outwards and vessel Q tapers inwards as shown. Both vessels contain a liquid. The depth of the liquid in the vessel is same. It's same. The liquid in vessel P is twice as dense as liquid in vessel Q. Therefore, consider the density of liquid liquid in vessel Q is rho Q. Therefore, density of this liquid would be 2 rho Q. We know the pressure of the liquid is H rho G. Therefore, we have to determine the ratio of pressure due to the liquid on the base of P, pressure due to the liquid of the base of Q. Yes, this is equals to H two into rho Q G by H rho Q G. This is 2 by 1 and it is at answer A. Therefore 16 A. At question 17, a motor is used to lift a load vertically upward. Load has weight W. Motor produces useful power output P. The load is lifted at constant velocity V. Which expression gives the time taken for the motor to lift the load vertically upward through a distance d? We know motor power is P. Therefore, we know power equals to force into velocity. And force here is weight W into velocity V. And here is the question is, which expression gives the time taken for the motor to lift a load vertically upward through a distance b? Therefore, velocity equals to b by w, and time equals to distance by velocity. Distance by velocity, therefore distance into w by t. This is similar, exactly same as wd by p. And 17 answer is C. Question 18. A lamp is switched on for 2 hours. The power input to the lamp is 1 watt. The energy given out by the lamp as the light is 7 into 10 to the power 3 joule. How much energy is converted to other forms by the light, by the lamps? Therefore, energy input power equals to energy input equals to 1 into time 2 hours into 60 into 60. Energy input is 72 100 joule. And energy output is here 7,000. This equals to 7,000. Therefore, energy converted to other forms is 7,200 minus 7,000 is equals to 200. And it is at answer B. 18, right B. And at 19, an object of mass m is dropped onto the surface of two planets X and Y, which have no atmosphere. The height from which the object is dropped and change in gravitational potential energy of the object for each planets are given in the table. The acceleration of free fall near the surface of planet X is gx. What is the acceleration of free fall near the surface of planet Y? Now we consider gravitational potential energy of planet X daily mg m gx, height is 3, therefore 3 mgx, and let acceleration of free fall near the surface of the planet y is yb gy. Therefore del 4 del E, gravitational potential energy, for the planet y is m into 4 into gy. If this is equation 1, this is equation 2. If I divide equation 1 by equation 2, this gives 1 by 4 equals to 3 gx by 4 gy. Now making gy equals to, therefore gy, acceleration of free fall near the surface of planet y is 3 gx, and it is at c, therefore 19, answer is C. Question 20, unknown tensile force act on a metal wire. The wire does not exceed its limit of proportionality. Which two measurement enable the strain of the wire to be calculated? You know, strain epsilon, small epsilon, equals to extension by original length. Therefore if we consider this, the unstressed length, that is original length, and the original length of the wire and extension of the wire, therefore if we know these two measurement, value of these two measurement, we can calculate strain. Therefore 20, answer is B. And I have solved question 1 to 20 in this class, and I hope the class will be beneficial for the student who are going to take part in Cambridge AS level or similar standards of examination, and my best wishes to all who are gonna join my class over YouTube. And one message, one request is, if you think my class is beneficial, please subscribe my channel. Here is the end of my class.